Hi, my name is Sushma Padmanabhan, and this is the project for the Machine Learning Foundation course. We are going to be working on developing the machine learning model for predicting the energy output. I'm sharing my desktop. The goal or the problem statement and the type of machine learning that we will be using is, of course, the goal is to predict the energy output of a combined cycle power plant, and it has 4 different variables on which the power generation is being calculated. We have historical data, so we will be using the supervised learning method, and we'll be using the regression learning task for training of a model. The outcome and the output metrics are as below. The outcome is the low cost of per megawatts of energy produced, and how do we ensure the high optimization of resources. The output metrics here that I'm calculating is the regression model metric, the MSC or the RMSC. Because given that the variables are very much in the range, it would be fine to have slight bit of an error with the predictions as well. The modeling method that I'm using or building to use the building of the model, there are few features that influence the energy output. They are depicted in 4 different columns in the data sheet, which is temperature, pressure, humidity, and vacuum. So I will be using a permutation and combination of one or many of these features. For the validation approach, I'm using the fixed validation set approach. I have split my data into 60, 20, and 20, which is 60% training, 20% of validation, and 20% of the test data. I have calculated the correlation coefficient to measure the relationship of the features and targets, just to emphasize the strength of the model. How do we interpret the models? I'm going to share my Google Sheet. Here I have created 3 different Google Sheets, which are the first one is a sheet which has the model which has taken into account all the 4 variables as features. The second model takes into account only the first 2 variables as the features, which is temperature and exhaust vacuum. And the third model has been built on only ambient pressure as a single variable. For each of these variables, I have split the training data, the validation set, as well as the test data into 60, 20, and 20%. For each training data, what I did was I have used the training model and predicted the electrical output, and then compared the electrical output with the predicted with the given target, and form correlation as well as the RMSA. The same process was redone for the validation set as well as the test set. And similar process was followed for each of these models between training, validation, and test set. So in a summary, this is how it looks. 3 models, 4 features in the first one, 2 in the second, and 1 in the third. The correlation coefficient, as you can see, when all the 4 variables were being considered, it was 0.99. Whereas the correlation coefficient dropped when we consider only one feature, which is 0.54 in model 3. The RMSC in model 1 was 2.38, whereas compared to model 3, it was 14.27 when only one feature was being considered. So all in all, I would be choosing model 1 for as a model of my choice, since the RMSC is lower and the correlation coefficient is high. Thank you.